Back in JSBin, I'll start with the primitive types. I'll create a number and I'll assign it a number. And then I log that number. I won't execute this code right now because I think it's pretty clear what will happen. I'll then create a new variable, another number, and I also assign a number, and I log another number. So let's run this code. It prints 5 two times. Next, I set a number equal to 12, and I repeat the two console logs here. So I print out a number and another number again. So what would you expect to show now? See that we print 4 times here. We get 5, 5, 12, and 5 again. So another number is still 5, even though a number was changed after being assigned to another number. And the reason for this is, of course, the behavior I described. With primitive types like numbers, a copy of the value is created, and therefore another number has the value 5 and no reference to a number. Therefore, it doesn't care what I do with a number. And this changes if I switch this with another example. I'll create an array 1, 2, 3. And first let me remember what type an array has. So I'll run this code, and we see that an array is actually an object. That's important to know because an object is a reference type. So if I now create another array and I assign array, now let me print both values. So I print the array and then I print the another array. What do you think we'll see? Well, we see the array 2 times. Of course, because I'm creating it here and then I'm assigning it here. Now, the interesting part is if I change the array, and I'll use a method here to push a new item on it, and I'll come back to array methods in the next module. And now I print both arrays again. What do you expect to see? Well, you see that we got 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 4 2 times. So even though we didn't change another array, it still got changed. And the reason for this is the behavior I just described. Objects are reference types. Therefore, array only holds a reference to this value, to this object. And when we assign array to another array, we copy that reference, this pointer. Now, when I push a new item on array, the value itself is changed. The 2 pointers aren't changed, and therefore both point to the new value with the additional 4. That is important to understand. Now I'll get rid of these 2 logs, and I'll change this code. If I don't push a new item on this array, but instead I set array to, let's say, an array which holds A and B, 2 strings. What do you expect to happen if I now click run? Well, now you see I got A, B, and then still 1, 2, 3. Isn't that against the logic I just laid out? No, because now I'm creating a new object here, and therefore I'm not changing any object to which this variable was pointing to or to which this pointer was pointing to, but instead I'm creating a new value with a new pointer. Another array still has the old pointer to the old value, which is still there in memory. I didn't overwrite it, I just reset or reassigned the array variable with a new pointer to a new value. Therefore, I can now print out both. And that's the difference. With array push, I was editing an existing object, so both variables with the identical pointer were therefore, well, updated. And with this approach here, I'm actually creating a new value. Therefore, another array doesn't care about this. It's very important that you understand this difference between primitive and reference types. Because the behavior of reference types can lead to many bugs, or to confusion at least, when your code doesn't work the way you expect it to work, because suddenly a value doesn't have the value you expect it to have, or a variable doesn't have the value you expect it to have, because you forgot that the variable was actually holding a pointer to a value which got changed in some other place in your app, maybe in another file. So this is extremely important to keep in mind and to understand. This is how JavaScript works and how these two different types of types, these two different categories of types work.